Hello, ladies, gentlemen. Well, God only knows what watches my channel anyway, but, yay. So, one of our community members, Zhang, actually has sent me a bunch of stuff to take a look at, because I wanted to do a video on fiber optic stuff. Actually, I want to do some videos touching on fiber optic stuff, and I do apologize for my tardiness at getting another video out, but honestly, I just haven't felt like doing anything. So, here it is. Check this out. We've got some really cool stuff. So these are all PLC splitters. Now, before I get into the video, I wanted to show you guys a little difference. I didn't know how to make a demo to explain this, but I went on the internet, and if you just look up PLC versus FBT splitter, this website popped up. I can't remember what the link was, but I printed it off quickly anyway. So the old way of making a Pon splitter, coupler, whatever, would be to literally take the fibers and twist them around your lead fiber. So you're 1 in, you're 8 out, or 12 out, or whatever, right? And then fuse it and keep twisting it until it literally, see what happens here? It twists off into like basically one, so you're combining all of them. That was an old, inefficient way of doing things that was shit. Okay, so now if you take a look at this, the way that we do it now is using an optical circuit. So essentially, there are optical paths made in a piece of glass. I'll take one of these apart and show you. I wanted to do it under microscope, but honestly, I've tried. You really can't see anything, and I don't have the skills to show you what the circuits look like internally, but they kind of look like this, okay? So I'll bring this up a little bit closer. So essentially, you'll have your primary coming in, and then it forks off to each of the leads. So essentially, I'm going to demonstrate this in a second, but light coming from your source, being the OLT, feeds out and broadcasts out to all of the different branches. Now coming back, they're kind of isolated from each other because the light is going in one direction. It's all funneling back forward. Wait, that was horrible English terminology. It's all funneling forward towards the OLT, basically. So the OLT funnels out to all the sub-branches. The ONUs actually all hit back towards the OLT. And here's a better description right here. This is kind of what the waveguide looks like, the optical circuit. And so it's cut into glass, basically, to do this. It's just a bunch of forks, basically, right? So now I'll start off with describing to you. We're going to jump topics quickly. All right, so let's see here. Any one of these will be a great way to describe it, but I wanted to show you all these different units before I actually demonstrate what I just showed you, okay? So these are all splitters, okay? They're 1 to 8 splitters, because that's a really common split, okay? So this is the kind of one that, you know, realistically, that's supposed to be mounted in the back of a tray, right? But you know what? If you've ever seen the inside of a cabinet done by a major big player like Bell Canada, Rogers, TELUS, Frontier, Spectrum, these are just stuffed in the side of the cabinet, and then these are all patched into things, because you know what? Most of the technicians don't do a decent job because their parent companies really don't want them to do a decent job. They want them to be fast, right? Now, if you're a smaller company, you're typically going to take more care in the installation of these, and you're going to put them in properly and make a really nice setup within your cabinet because you want it to be reliable. So these guys here, as you can see, it's got 4 little bolt holes that you can, you know, screw into the back of your tray, and then you've got your 1 in, and you've got your 8 outs here. Very, very polite, very nice looking kit right here. You can also use these inside of FOSKs or whatever. This guy here is designed to go into a cassette holder. Okay, so you'd have like a 1U. I don't have one here. This is all equipment that's been donated to me by Zhang and Associates so that I can demonstrate this. So I don't actually have the rack mount piece, but you could like pop these. They stack. You usually have like one above another, so you'd have like 2, 4, 6, sometimes 8, depending on the size, inside of a rack plate. And so in behind it, there would be nothing, right? So this is basically one of these just packed inside of here. This is one of these, except, you know, just inside of this little package. So different packages. And all these packages actually have testing. They've got the results of the tests kind of like you would do if you're, validating or verifying a Ethernet network with one of those fancy fluke testers that the more pretentious people like to run around with that don't necessarily need them because they're only used in government application or really, really, really tight tolerance applications. My cat's stealing my sheet of paper and dragging it across the floor. That's hilarious. So, yeah, this tells you what the test results are of each of the units. Okay, so now, as you can see, this one has one as well. I want to show you one more of these little guys, or actually these two right here. Let me grab a plate out of a FOSK. Okay, and actually, if you guys don't know what a FOSK is, this is an example of a FOSK. This was kindly provided by Golden Rural High Speed here in Ontario, Canada, which needs to be returned, by the way. So what a FOSK is a fiber optic splice container, or fiber optic splice can, we like to call them. Okay, so the whole purpose of this thing is you'll usually see them as a black canister about that big around by about that long with a bunch of cables coming into the bottom of it hanging on a pole line, okay, usually on a messenger wire. What's inside of those guys is usually trays like this. This is a different design, so I can't show you that exact model. There's tons of different designs, but this is your tray where all of your splices would go. You do your splice, you lay your splice connectors inside of here, right? And so this is where you would encircle your fiber strands inside of here. You bring them in, so your leads come up here, they go through here. I should actually do a video on dressing one of these. If I'm going to do that, I'm going to bring somebody in because I don't have the experience doing them personally that a professional would actually you'd benefit from. Okay, so now if we flip this thing over, there's another side on it, and this is where all of your fibers come in. Okay, so as you can see here, this is a distribution node, so we've got all these little home drops, right? We've got 4, 8, 12, 16 home drops here, okay? And then here would be your trunks. They all come in through here. So now that I've demonstrated to you the basics, a crash course of what a FOSK is, I'll show you what this tray, or this cassette, I think they call them cassettes. This is where this ties in. So these guys here are specifically for this application. So if you'll take notice here, whoop, come on, I'll just put this aside. You could take something like this guy here. Okay. There is another one that Jack sent me that didn't have connectors on the ends of these. They were actually just loose leads. But the idea here is that you can take these guys, so you can just tuck these into your tray here, and you can actually do your splits inside of your fiber tray. Yeah, my dressing is going to be garbage, sorry. So this should fit in. Oh, beautiful, it does. So this fits into one of these little slots here, right? And then you can dress your strands, bring them through. For the pros out there, you're probably going to be shredding me right now. You know, that's the funny thing about YouTube. Everybody loves to shred everybody and prove how much smarter they are than everybody else. I caught myself doing that in the past, but now I don't do that anymore. I am evolving. Here we go. So check this out. Alright, so this is basically what you would see. And so you would have your strands in here. Blue, orange, green, brown. They would come through, and they would be spliced in here, basically, right? I'm just giving you a rough idea of how these guys would install. This is actually a cool FOSK. If you guys want to see more content about, you know, like different fiber solutions and practices and how to do things in fiber optic stuff, let me know in the comments below so that I can try to get my hands on more of this equipment and do videos on it for you. So here we go. Now, I'm just lying these in here. I'm not actually doing a splice, but there would be splice protectors in here, and these would be going to home drops, obviously, right? Blue, orange, green, brown. And by the way, if you ever want to kick, you should see what the dirty old men back in the 70s and 80s used to use as rhymes to remind us what the color codes were in telecom, okay? So this is essentially what you would see. And you'd have your home drops coming in this side, and the splice protectors would be here. And then this would be your feeder coming from the OLT. So this is the input, this is the output. So that's when you see ones like this with the little silver piece on them, the PLC splitters, that's essentially what you're getting, is that this is designed to go into one of these trays to save space. It's for usually aerial or burial or pedestal. So if this is, you know, these would go in pedestals or they'd go in vaults is what we call them. Pedestals would be the units that you see at the side of the road. They're usually standing up. Vaults would be the ones that's like a plate in the ground. It's usually covered over in grass because dirt accumulates on them and when you don't go into them very often, and eventually snakes and spiders moving. All right, so now let's do some fun experiments with this stuff, okay? So I'm going to take this guy out of here for a second, put it aside. And this one here, I don't necessarily need to keep it out anymore because you guys get the gist of this, right? You guys figured this out? Did I make my point, I hope? All right, so moving on. Now to the science part, because this is usually what people want, and we're already 10 minutes in, and usually by this point, half the viewers actually drop off because they're like, nothing's happening. Why aren't you giving us more context? Well, maybe because this video, if you don't have the context, you don't know what it's about, so don't watch it. All right, so what I've got here is, this is, the old terminology is a ruby. This is a laser source. I really probably shouldn't be doing that, but this is a laser source, or light source, okay? So what we use these guys for here is for producing light. We use these to troubleshoot and test connections, okay? So what I've got here, actually that adapter pulled apart way easier than it should have. Huh, this is actually what it's supposed to look like. That's press fitted. Cheesy. So anyway, you would use this for optical troubleshooting, okay? So this guy here is now producing red light. Now what I'm going to do, if you notice on here, there's a green cap, and these would all be black caps. They're all in the bag here. Yes, they had caps in them. You should always clean these before you marry your parts together. I think I've got a cleaner right here for it. No, I don't. So you would click in each one of these when you marry your connectors together, but this is a demo video. So this is your input. These are your outputs, okay? So now I want you to check this out. Watch. So if I plug this in here, you can see the light pretty distinctly, I think. I think you can see it pretty good. If I plug this in here, you're going to get light out of all 8. Isn't that neat? Yeah, I'm looking at the screen to make sure I can see this, by the way. So yeah, you can see very brightly that there is a lot of light coming out of these. But you can also see that it's diffused because it's being split. There's the brightness right there, right? Now, if I put this in here, you can see that the brightness is way weaker because that light is being split. It's being distributed through these 8 ports, okay? Evenly. So this is the downstream section. Now, to demonstrate the PLC, watch this. I'm going to plug this into port 8. Okay, now, you'll notice that it's the brightest one is right there out of the feeder, right? The upstream port. But the other ones, there's barely any light coming out of them. In fact, if you take a look, you can't really see anything. That is directly indicating what's going on here. Does this make more sense now? I'm going to put this to the side. You see? Because the light is being funneled in this direction. So if I plug in any one of these ports here, you can see that it's coming out of this one, but barely anything out of those ones. There is light there. You can see light, a little bit of light in these guys, but barely anything, right? It's because, as you can see, all the forks are going downstream, not upstream. So it's flowing the way that water would, or light, or in this case, right? So I'll move this one back over again. Isn't that interesting? There's no magic here. There's no trickery. It's just literally funneling like this, right? So they're coming in this way like that. So the light's coming from this direction, right? Let's take a flashlight here. So light's coming from this direction, right? And if it's like this, it's going to go down both those paths. But if the light's coming down one of these paths here, how is it going to go that way and then come back up this way? Obviously, reflections in that will come back this way, but no, the light's going to go in that direction. It's as simple as that. There's nothing more complicated to it. I don't know how else to explain it, but that's basically it. So this is a splitter in action, right? Isn't that kind of cool? Okay, so that's the splitter demonstration that I wanted to show you guys. And I mean, like, optics aren't necessarily as exciting as, you know, some of the cool programming stuff that I do. And I've got another couple of videos coming up. Tycon sent me some stuff, and HiConnect sent me some more stuff. And I want to do some more videos with some microtik programming and stuff. But let's open this thing up and actually see what's in it. You're going to be surprised here. Would you look at that? They're all SC connectors with couplers. Isn't that cool? Which, by the way, if you're ever in a pinch and you need you need something like one of these little guys here, that's literally all that this is. Look, I'm going to dismantle it. Look. See? There it is, right there. There's your little... In fact, if you ever needed one of these guys and you didn't have one available, you could probably 3D print one. It looks like it's crazy glued in there, by the way. So I'm going to try not to destroy this because I want to use it for demos. Alright, so look at that. Does that look familiar? Does that look familiar to you? Ha ha ha, that's because this is how most of them are. Inside of here, it's going to be the same thing. If I open this guy up, it's going to be exactly the same thing. In fact, let's just take a quick second to do that because I'm going to beat this dead horse. Which also means that if you're ever in a pinch, you can now know where you can find things that you need to do stuff. The big difference is that these guys are all very, very fine strand. These are heavy jacketed, okay? So like these are designed for cabinets. These are designed for trays and internal, right? So here we go. Now I should be able to pop this guy open. Let me grab a knifey. Kniff. Oh, there's one left. Should be exactly the same thing inside. Look there. Oh, look at that. Those are fine strand. That's literally just... Oh, I see. Look at this. Isn't this cool? Can you guys see that? So they actually took all of these strands here and they actually glued them into the PLC. So they took a bunch of tails here and glued them into the PLC there. Isn't that cool? Now, if you don't want to know what FBT and PLC stand for, I can't remember, but look it up. Okay? So once again, as you can see, now this one here you wouldn't dismantle and, repurpose in a cabinet because, as you can see, these are just single strands with their cladding on them, right? Their basic jacketing. And then it goes into your buffer tube and then into your full jacket for protection so that you've got your rigidity in the cabinet. If you try to run this loose inside of a cabinet, you're probably going to run into trouble. Could you use this inside of a FOSK? Probably, especially if you're skilled, because there's a nice little coil here on the upstream, and these are short leads here, but you could cut these guys off here and just pull everything off, and you've got yourself a splitter if you really needed one. So realistically, 99.999% of all these guys are exactly the bloody same. This is basically just a cassette to put these guys in. And you know what? It really doesn't even matter what order I put these guys in either. I could just go all willy-nilly with these guys and toss them in here, and who cares, right? All that really matters is that you've got your demarcation of your inbound and your outbound, because all the outbounds are equal, okay? There's no discerning the difference to these. Take a look at this while I'm putting this thing back together. I'm putting this thing back together for the purposes of reusing it in the future, because maybe one day if somebody actually wants me at an event, I could actually like set up a presentation or something to actually show you guys stuff. But now that I've made a video mentioning that, anybody who gets that idea will probably do it and do a much better job than me. There we go. We're going to carefully twist this guy in place, like so, because we don't want to kink any of these or break them, because any kinks will create attenuation. So we want this to be a nice free flow. There we go. Get in there, you monster. There, maybe I can do, there we go, that'll work, like just like that. C'est parfait. What I should have done actually is put the leads over top of that if I was any kind of not a hack. There we go. That's back together now. Alright, so there we go. I just demoed some neat equipment that Zhang has provided to us kindly to examine and pull apart and demo. And yeah, this is basically what I came to do. I don't know what else to tell you. That's it. We're at 20 minutes exactly, and yeah, there's some splitters, some optical splitters. There's really no magic to them. It's literally just glass. And actually, one thing I should mention as well is just like when we're talking about antennas with 5 gig is 5 gig is 5 gig is 5 gig. Antennas are not all made the same, of course. Some of them are better than others, but a frequency is a frequency. It's the same thing with light. Light is light. So if you've got GPON, I believe the GPON is what, I think it's down in the 1300 range. And I believe that once you get up into XGS PON, it's 1600 nanometers of light. So these guys can actually carry multiple bands of light at the same time. And actually, that happens quite frequently. You might actually have something in the 1300, you might have stuff in the 1500, and then you might have stuff in 1600. They're all different frequencies within the electromagnetic spectrum, and in this case, in the optical spectrum. Okay, so what we're talking about here is that you could actually have this connected to a cabinet, and you can have a 1 to 2 splitter, and you'll have like a OLT, an XGS PON OLT, and a GPON OLT, both feeding into the same 1 to 2, and then that could feed out to one of these lines here. Okay, and then you basically have both your 10 gig and your 1 gig PON networks running on the same glass, because the glass itself, when we're talking about single mode, we've got a couple of main differences between these. I believe that there's, look them up, there's the OS for single mode, and for multi-mode there's OM. Single mode clearly goes greater distances. I'm not going to get into those details in this video, but glass is essentially glass, and you can, for the most part, run different frequencies of light over them. So these guys are useful for pretty much whatever you're trying to do. The big difference is whether they're APC or UPC, which is the cut of the glass on the end, whether they're angled, which these ones are, or they're flat. So the angled ones are apparently lower loss. The flat ones are higher loss, because with the angled light, when the light hits it like this, if it's flat, obviously the light's going to hit it full on. But if you angle it, it's going to actually penetrate better through the coupling, the connector, because otherwise you still have reflections off of every single one of these connectors. So there we go. I unintentionally gave you guys a crash course in PON type fiber optics, and demoed some equipment for Zhang. So there we go. I hope that you guys enjoyed this video. I hope that it was at least somewhat educational and gave you guys some answers to some questions that you might have had. And I also hope that it demoed this equipment for Jack, because they've got all sorts of neat stuff that they're trying to get out into the market. They're kind of a new player in the market, and yeah, I want to see that they succeed, because they make decent equipment. There we go. That's all that there is to show, everybody. So anyway, I hope that you enjoyed the video. Don't forget to like and subscribe. Leave a comment below if you've got any questions about any of the aforementioned stuff that I produced or mentioned in this video. And I guess I'll see you guys on the next one. And by the way, I think the audio is much better in this one. I used an actual microphone right here. Tap, tap, tap. And the Anchor webcam. So, bye guys.